Audio Jungle. Audio Jungle.
So last lecture you had seen that the general equation of or fundamental equation of thin airfoil theory. What was that? It was 1 upon 2 pi 0 to c gamma g dz divided by x minus j. Okay, minus, or you can write now equal to also, because it was minus sign, so that you had taken this side, you can say. So it is nothing but v infinity alpha minus dz by dx. So this was what? This was the fundamental equation of thin airfoil. Okay, for different type of the airfoil you can take the different condition, like for the flat plate you can say dz by dx, that value will be 0. Similarly you can take calculation for cambered airfoil, for symmetric airfoil also. Okay, so this is the general form, and from here you can get the final equation for what type of airfoil you want. It is cambered, or it is thin, or it is flat plate. Okay, so this was the fundamental equation we had seen in last class. Now the important for the gate topic is, they are asking question, what is the lift coefficient for thin airfoil? Okay, what is the circulation, what is the vorticity for thin airfoil? What is the total circulation around the airfoil? Like that the question they are asking. Okay, what is the moment at quarter chord, pitching moment coefficient? What is the lift coefficient, what is the pitching moment coefficient at quarter chord? Okay, like that the question they are asking. Fine. So now we'll go for the calculation of the circulation, total circulation you can say. We'll go for the vorticity calculation, we'll go for the calculation of lift coefficient, we'll go for the calculation of lift, we'll go for the calculation of pitching moment, about leading edge, about quarter chord also. These are the small parameter they are asking in your exam. All right, I told you this is the general form or fundamental of fundamental equation of thin air, so they are not going to ask this derivation directly. From here you can derive, so that almost you can have in your semester exam, but here in competition I told you, from here you can calculate total circulation, from here you can calculate vorticity, from here you can calculate lift, you can calculate lift coefficient, you can calculate pitching moment coefficient, about leading edge, about quarter chord. These are the questions they are asking in from thin airfoil theory. Hope you understood. Okay, so now we'll go for the calculation of lift coefficient for thin airfoil. Okay, so before going to calculate lift coefficient, we'll have to get the value of total circulation. Okay, so let me write here total circulation. Total circulation or circulation of thin airfoil. All right, done. Now if you say total circulation, so diagram, if you remember, okay, where is the I had shown that vorticity and all. So if you go for this diagram, and for here I'm little bit I'm going slow so that in one time you can understand, because more and more time don't give for this type of topic, because weightage is what 2 to 4, so better will go slow and I'll explain in one time and it will be sufficient for you. Okay, don't waste your time unnecessarily. Here the chord line you have shifted, camber line you had shifted on chord line, so the another axis which was xi or zeta, I told you it will be represented by this. Earlier it was zx axis. Okay, then you had calculated dz by dx, that was the slope and all. But now here what you have taken, that assumption is what you are now going to calculate, like induced velocity at the chord line. So for that what you did, camber line, because you are considering it is like a symmetric airfoil, so, or the assumption of thin airfoil, you can say that camber line and chord line basically it is almost same. Okay, because it is very thin airfoil. So camber line is what shifted to the chord line, so you will show the uh, verticity here. So it will be like, see, this will be the verticity along the chord line, okay, and somewhere you may get the induced velocity which was w. Okay, and it was at distance x. Okay, at zeta distance you have taken one segment. Okay, and this segment is nothing but d zeta. All right, now if you write the value of total circulation, so what will be the total circulation? This total circulation is what denoted by capital gamma, you can say. This total circulation is what denoted by this, you already have seen in your previous classes. Circulation gamma, you had seen circulation, that was the gamma you had seen. Okay, now if you check, this is nothing but gamma is equal to, because the whole length is nothing but, because the whole length will be the chord length. Yes or no? The whole length will be the chord length, hence it is 0 to c, and that vertex sheet, it will be represented by small gamma, and along the chord and this axis is what xi axis, so it is nothing but gamma of xi into, for this segment you are going to calculate d xi, for this length you are calculating, so this is nothing but total circulation. This is nothing but total circulation. Okay, always remember, this is nothing but total circulation. What is the gamma? So you gamma xi itself is saying like along this axis. Okay, now only gamma I can write. So gamma is what? It is the distribution of verticity distribution of verticity over the element of camber line Okay, camber line, what is the camber line? It is nothing but dxi, you can say. All right. Now, if you are calculating circulation, total circulation, so it will be total chord length, which is nothing but 0 to C. All right. Now, if you calculate this, you know very well that Kutta-Jokusi theorem. What was the Kutta-Jokusi theorem? It is nothing but Kutta-Jokusi theorem, if you remember. It was nothing but L rho u gamma d xi, because if you remember Kutta-Jokusi theorem, so it was lift is equal to rho u and circulation. And what is the total circulation? Total circulation nothing but gamma into d xi. You can write this, no issue. Yes or no? And one more thing you know very well. What is that? It was nothing but L is equal to, in terms of pressure, it is nothing but lower pressure, lower surface pressure into upper surface pressure, and the length, if you check, it is along the x-axis, so it will be dx. Yes or no? This is what along the x-axis. Okay, both you can check, you can equate that, then what you may get? You may get PL minus PU is equal to, check here, and this ds itself is nothing but, because it's along the xi axis, so 0 to C, PL minus PU into d xi. What will be PL minus PU? Check, it is nothing but rho u. Okay, and this value will be what? Rho u into gamma. Check, you compare it, so you may get, what is the PL minus PU? It is nothing but delta P. So basically, what is the total delta P? If you check, it is nothing but rho u velocity into gamma. Okay, this is very important, you need to remember. Delta P is nothing but rho u into gamma. Now in our case, we had taken the velocity. What was the velocity? We had taken the velocity v infinity. Check in our case. Now, if you previous that derivation, if you check here, everywhere, this one, or any diagram, if you check previous diagram, then that free stream velocity we had taken v infinity. Okay, so instead of u, you have to write v infinity. See here, this was the v infinity we had taken here. Okay, v infinity. So now you can, because generalized formula I have written. Okay, so like it is u or v infinity, it's your choice, but previous, if you check, it was taken v infinity here. No, so this was alpha angle of attack and this velocity was v infinity. So now you can replace this rho v infinity gamma. All right, always remember, this is very special formula. Basically, over the thin air foil, that pressure difference you got, and it is nothing but rho v infinity gamma. All right, what you are talking here, it is for in a small angle of attack. Okay, it is for a small angle of attack. Now total circulation you had seen. What will be the total circulation? If you calculate that total circulation, for thin airfoil, so it will be circulation is equal to 0 to C gamma xi d xi. If you write the value of gamma, okay, then it will be that value will be V infinity. Directly I am writing, this is the one derivation, okay, because gamma xi value if you go and write it, so it will be lengthy again. So that better you just remember the value of total circulation. Okay, gamma xi if you again write it, then it will be very washed calculation, so I'm not going in that. So what I'm going to write, gamma xi value directly I'm writing, and 0 to C I'm going just convert it into that polar value. Okay, substitution will be there, and that limit will be what, 0 to pi now. So it is nothing but V infinity C is the chord length, alpha angle of attack, and 0 to pi. Okay, 1 plus this step I have written here directly, because if you go, so this is the very long actually derivation, after this it will come, but for get total circulation formula is important. That derivation you are not going to do in exam also, you know very well. If you want to prefer the book, you can prefer that fundamental of aerodynamics, so that full derivation is given, but I will suggest you just remember this value only. Okay, so if you solve this, so total circulation you may get, if you solve this 0 to pi 1 plus cos theta d theta, now it's simple integration only. So what you may get, you may get pi, okay, alpha c into, this is very special formula there. So this is the total circulation for the thin airfoil. This is very very important. Okay, very very important, always remember. Okay, c is nothing but, this is very very important, it will help you in your exam. Okay, angle of attack, AOA, angle of attack, free stream velocity. Okay, very important formula. Okay, this formula you need to make a note of it. Now you have to calculate lift also at the same time. As I told you, these are the parameters you need to calculate, and they are asking in exam also. So how to calculate? Very simple, by Kutta. Remember Kutta-Joukowski theorem is what valid for thin airfoil. Okay, so what was that? It was L is equal to rho u circulation. In our case, u is nothing but V infinity into circulation. Just now you have calculated what is the circulation. Let me write. Circulation is pi alpha c V infinity. Pi alpha c V infinity. So what is the lift? Lift is nothing but pi alpha c, okay, rho into V infinity square. This is what lift. Dear, this is very very important result. Okay, all formula whatever I am giving here, if it is a small derivation, so I am deriving. If it is lengthy, so directly I am few steps I have written directly. Like here I told you, because if I will go for the derivations, it very lengthy. Okay, it will be very lengthy. So directly I have shifted to this, and better you also do the same. For the full derivation, you can go for fundamental of aerodynamics. So due to time shortage, I am not going to derive full derivation, but the important points I am writing here and deriving. Okay. So this is the lift. This is very important question will be asked to you. Okay. So always remember, this is the L. This is the lift. Okay. Calculation for the thin airfoil. It is nothing but pi alpha. One more thing I will tell you. Actually, in reality, whatever the alpha you are getting here, everywhere, in fact here or anywhere, it was sine alpha. Actually, it was sine alpha. This formula will be like this: pi, okay, c rho v infinity square, and this was sine alpha. But for a small angle of attack, sine alpha approximated to alpha. All right. Anyway, so don't think about how this alpha directly how it can come. No, it is sine alpha, but for a small angle of attack, sine alpha will be approximated to alpha only. So now we will go for the calculation. Third point, it is nothing but lift coefficient. Lift coefficient CL for thin airfoil. Yes or no? So what is that? If you go for it, the general formula, you know what is the formula? L lift is nothing but half rho v square s into c, and you are taking unit depth, so c into 1 will come. Okay, actually this is the area, half rho v square, not s. S actually is equal to c into 1. Got my point or not? This s is nothing but this value. Actually s area is nothing but chord length into 1. Okay, there is no span, because it's a thin airfoil and you are considering airfoil. It's not a 3D. Airfoil means what? This is the one, and this length is nothing but unit. Okay, unit length, and here it is nothing but chord. So what is the s? C into 1. So basically this is what 2D you can say. Okay, that depth is not, depth is unit, span is what? Unit. Anyway, hope you understood now. So what is the L? L is nothing but half rho v square into c. This is the one, but in previous what you have calculated lift here, this is the value. So this value also equate with the previous lift value, and what was that? Pi c alpha v infinity square into rho. Yes or no? If you check this, okay, and this v is also obviously v infinity. Here you can make v infinity. Now, so value will be cancelled out. What do you make it? A half rho v square s into cl, lift coefficient. I forget to write, and cl. Yes or no? So what will be the cl? Calculate it. It is nothing but 2 pi alpha. Check, all value will be cancelled out here. Yes or no? This value will be cancelled out. Chords to chord cancel out. Cl you may get 2 pi alpha. So actually it was 2 pi sin alpha for small angle of attack. Sin alpha was approximated to alpha. Hence, what is the lift coefficient? 2 pi alpha. Okay. So what value we have calculated here for thin airfoil? What we have calculated here for thin airfoil? We fundamental equation. Then what we had calculated? Total circulation, total pressure. We have calculated lift. We have calculated CL. Yes or no? These are the value we have calculated. Till now, I think this one is clear to you. Okay. Now, if you talk about the next point, which is nothing but moment, all the value here you have calculated. Okay, and you need to remember because it's very important. Okay, L is nothing but I think pi alpha c rho v infinity square. Similarly, rho v infinity gamma you had calculated, and circulation also I don't remember. Let me check what was the value. So this pi alpha cv infinity, pi alpha cv. So this one if you remember, then you may able to like solve the question, no issue. All right, good. Now we are going to calculate the moment coefficient. So what is the next part which is important is moment. Okay, and moment coefficient, these are the unknown, we have to calculate that also. So these, how many points? 1 2 3 4 5 7, only 7 point. If you remember, believe me, the question thin airfoil theory definitely will able to solve. Okay, it's very simple only, it's not tough, it's very simple only. All right. Now so we'll go for the next and we'll write calculation of moments about leading edge. Okay, so we'll draw the diagram neat and clean and then we'll go for the calculation of it. So okay, just say this is the one point which is nothing but leading edge somewhere, because you are going to calculate moment, so definitely on the chord of the airfoil there will be a lift force, and that lift formula also you have seen. Okay, anyway, so I'm considering somewhere here, this is the one point, dzi. Okay, and this distance from the leading edge is nothing but j. dzi you have taken one segment. At this, definitely there will be a vertex and there will be a circulation. Yes or no? So I can say this is the one point where you may get lift force, and that lift is nothing but dl. And why you are getting lift force? Because of the circulation, because you have seen if there is the circulation, if circulation is there, so by Kutta-Jokuchi theorem, circulation is there, so lift will be there. It is 100%. No, it is proved already. If circulation you got there, then definitely you will get lift force. Okay, and what is the circulation? Circulation is nothing but, you had seen, it was gamma xi into d xi. If it is along the chord, so it is 0 to c. Anyway, we'll see that. Okay, but at least at this segment, that circulation is nothing but gamma xi, gamma d xi, better to say. Now if you take the moment about this leading is, because the length is given, so you can write here taking moment about leading is. So check what will be the moment. It will give anti-clock or clockwise? It will give anti-clockwise. No? The lift force is here and you are taking moment about this point, so it will go, it will be anti-clockwise. Okay, at this point it will be anti-clockwise. No? Because force is what here and point is here, so this force will try to rotate about this point, so this rotation will be anti-clockwise, so you have to write minus, and for along the chord, so it will be 0 to c. Okay, and what is the value of like this lift force? So lift, as already have told you, that moment is nothing but force into distance. What is the force? It is nothing but dl is the lift force for this small segment. Lift is the dl into what is the distance? Xi. Yes or no? All right, now you can write y minus sign because it is the anti-clockwise. All right, now you know very well what will be the lift. You have seen that previously. Okay, lift is nothing but, check here, it is already explained. If this is the circulation, so from the circulation you can calculate the lift by the Kutta-Jokuchi theorem. So rho into circulation, circulation is this gamma, or then you will get dl, that is the lift. So I can write here directly, dl is nothing but rho, velocity we have v infinity, into d circulation. So this is the d circulation value. Yes or no? 0 to c, dl value I can write here rho v infinity, and d gamma is nothing but gamma g di into already one distance xi we have, and this is into d xi. All right, this is the value of moment about leading is. If you write minus, you can take to like rho v infinity you can take outside. So what you may have, rho v infinity 0 to c will have a gamma, check, this is the value. Yes or no? Now again this is the one calculation you have to put gamma xi, like here I told you that gamma xi value, if you write completely, see here also I had shown you this gamma xi, if you write completely, this will be the value gamma xi 0 to c gamma xi d xi. If you write, this will be the total value. You have converted into parametric form, 0 and theta, I mean 0 to pi limit, and then it is converted into theta, that length zeta you have converted into theta term, right, component sine cos. So this was direct, because it will take time to convert this, so I am not going to convert directly. Same, just like here I have written, same thing here also we can write. Okay, so what will be the value? It will be After integrating and 0 to c, it will be 0 to pi, and if you all think if you do, then what you may get? You may get, because this is the zeta d xi, so it is zeta square by 2, so 1 by 2 also will come, so you may get half, rho is there, 1 by rho is there, okay, half will come, and velocity term will also come, so half rho, this is nothing but v infinity square, or minus sign is already there, c square, okay, pi alpha by 2, this will be the complete value. So this is the moment about leading edge. So this is minus, this is what, dynamic pressure, so you can write q infinity c square pi alpha by 2, okay, fine. This value you need to write directly here, and remember this formula, this is very very important, okay, there should not be any confusion. Actually that step I have written directly, but I will suggest you, no, don't go for that all steps, it is not required. What is the important? I told you that formula you need to remember, okay. If you have remembered the formula, your task will be easy. If you have not remembered, if you go for derivation in exam also, it will give so much pain to you, and I will suggest don't go for it, okay. Derivation is not important at all. The important point I told you, it is nothing but the formula. So this is the moment about leading edge, always remember. Now we'll go for the moment coefficient about leading edge, yes or no? So that will be very easy. Next we can write moment coefficient about leading edge. What is the moment coefficient? It is cm. It is about leading edge, hence cmle, yes or no? So it is nothing but cmle, and what will be the moment coefficient? It will be the moment about leading edge divided by equivalent value. What is the equivalent value? Simple, whatever the uh, value of that force into one perpendicular distance, yes or no? Force into one perpendicular distance. So what is the force? It is nothing but lift force, that is half, or better to say, one more thing you can do, you know that force is nothing but pressure into area. Better, what is the pressure? Dynamic pressure, q infinity into area s. So q infinity s will be the force into one perpendicular distance. Here if you write, then the total length will be chord length, okay. So you can say mle divide by q infinity. Already I think you have written in terms of q infinity, so you keep it in that way only. Q infinity, what is s? S is nothing but c into 1 chord into 1 unit length you have taken, because it's airfoil, so there is no uh, span there, so into c is all, one more c is there, so it is nothing but q infinity c square. Now you will write the value of cmle. So check what was the value of mle. It is nothing but minus q infinity c square pi alpha by 2 divided by q infinity c square. What you may get? You may get pi alpha by, this is very very powerful formula dear, you please make a note of it, okay. So make a note of it, it is very very important question they are asking from here. All right. CMLE, right? Also you can write this CMLE pitching moment coefficient at leading is, so it is nothing but minus pi alpha by 2. Check what was the CL just now you have calculated, no? Lift coefficient. Here see, CL is nothing but 2 pi alpha. So what will be the alpha? Alpha will be CL by 2 pi. You can keep here minus pi by 2 into C alpha. Alpha is nothing but CL by 2 pi. What you may get? CL divided by 4, pi cancel out. So this is again very special formula for thin airfoil theory. If angle of attack they have given, use this formula. Okay, minus pi by pi alpha by 2, or you can use, if lift coefficient is they have given, you can use this formula. Okay, dear, question they are asking from here, so that's the reason I am saying just make a note of it, write in box. As I told you, write formula notes. In that notes you write this formula properly. Okay, fine. One very important point also they are asking. What was that? They are asking next I have to write. They are saying moment coefficient about the quarter chord point. What do you mean by it? Simple. That previous diagram here you have seen this in this diagram. Okay, same thing you can write and draw here. This is very special. Okay, this is very special. So today what I have taught here, what I have written the formulation and all, I cannot say all the derivation I have derived here. No, few things I have written directly also. But why I have written it because of the wasting of time. I don't want to waste your time and my time also, because this is the competition there. And don't suppose you are going to write theory and all in your exam. Okay. So for that reason only I have skipped, because it was lengthy derivation and steps by steps not required there in your exam. The final result if you know, the process if you know, that is enough. Okay, and here you had seen there is the lift generation dl, and why lift generation? Because of the circulation produced here. Quarter chord means what? C by 2 means the half of the chord. Okay, this is the C by 2, half of the chord. What is the mean of quarter chord? Quarter chord means 25%. This is what? C by 4. This point is called quarter chord. Okay, this point is called half chord, 50%. Okay, quarter chord means 25%. What do you mean by quarter chord? Means 25% of chord. What is the half chord? Half chord means 50% of chord. Now they are saying calculate moment coefficient about quarter chord point. Means at point I must say this is what A, this is what B, this is what C, and this is what D. Okay, now you are going to calculate moment at point B. So how to write here? I will tell you direct trick. Don't go for the full derivation again, okay? Because if you go at that point, so two moment already, one moment you have calculated at leading edge, and because of this force also you again go for at point B. Don't do that. Not required actually. You just use concept only and directly you hit go for the quarter chord. How to get it for the quarter chord? So simple. I'll write now. Quarter chord means what? Pitching moment coefficient at quarter chord. So it is Cm. Earlier we had written CMLE, LE for leading edge, but we are not going for LE. We are going for quarter chord. Quarter chord means at C by 4. Yes or no? C by 4. Quarter chord means what? C by 4. 100 divided by 4 means 25. Huh? So 25%. So it is also called C by 4. 50% means C by 2. Yes or no? So how to get it? So if you want to calculate here that moment, so one moment already we have here, and this moment is nothing but you have calculated CMLE. Na? CMLE here. Check at this point. You will get CMLE, and this CMLE is nothing but anti-clockwise at leading edge. So one moment already you have, and this moment called CMLE. Okay. So if you want to calculate moment at this point, quarter chord, so you have to write CM, pitching moment coefficient, CM, okay, L, E, it is quarter chord, so write CL by 4, okay, lift coefficient CL by 4. Now, now, you know this CM, C by 4, CMLE you have calculated, it is nothing but minus CL by 4. Why this is CMLE plus CL by 4? This how the CL by 4 will come? This is also one derivation. Directly I have written. You need to remember it. Okay. CL by 4. Or sometimes if you ask, then I will solve again. But if you want to try, you can try by your own also. So moment at quarter chord, if you want to write moment at leading edge plus CL by 4, then CMLE already you have minus CL by 4. Here you have calculated. Check this value. No? That I already have proved. So this value is nothing but 0. So pitching moment coefficient at quarter chord point becomes 0. Okay. What is the mean of it? Now the center of pressure and aerodynamic center concept will come. Okay. Center of pressure and aerodynamic center. So I was thinking this center of pressure and aerodynamic center I will teach you in stability class, because there in pitching moment longitudinal stability it is required. First only you will start from the center of pressure and aerodynamic center. So there I will explain you, but in short I will tell you. So what you got? Pitching moment coefficient at quarter chord. Okay, you got pitching moment, or you can say only moment coefficient, pitching moment, or you can say moment coefficient. I told you how many types of moments will be there. I told you that rolling moment, yawing moment, and pitching. So here obviously there will be pitching moment. That day only I explained why there will be only pitching moment. Pitching moment coefficient or moment coefficient about quarter chord. Okay, if this is 0, if this value is what, 0, so there is the meaning why it is 0, and if it is 0, then what will happen to you? So basically this point will be called as a center of pressure. What it is called? Center of pressure. So center of pressure, I must say center of pressure, it is nothing but COP. Center of pressure. So a point here, this definition you remember in stability class. I will derive that formula also, center of pressure and all, aerodynamic center. A point which about which moment or moment coefficient is 0, called COP, center of pressure. Okay, so center of pressure at the quarter quad point. Okay, for symmetric airfoil, or you can say thin airfoil, it will be 0. That moment will be 0, or moment coefficient will be 0. So moment about the quarter quad will be 0 for all value of alpha. It is not going to depend on alpha, because there is no alpha term for this. Doesn't matter what is the alpha, that pitching moment coefficient, or you can say moment, will be 0. Okay, will be 0 at the or about the quarter quad. So for symmetric airfoil, note, this is also asked in an exam. For symmetric airfoil, okay, for symmetric airfoil, both aerodynamic center and center of pressure, okay, at will exist, you can, at quarter. This is very important. Okay, you make a note of it. Okay, if it is symmetric airfoil, so aerodynamic center as well as center of pressure, both points will be existing, theoretically I am saying, will be existing at quarter quad point. Okay, and what is the point where moment or moment coefficient will be 0? It is the center of pressure. Is that clear? Then what is the aerodynamic center? Aerodynamic center is the point where the moment is what, constant, or moment coefficient is constant, which is not depending on the angle of attack. All right. So again, that aerodynamic center and center of pressure will be explained in stability class. Don't bother about it. But here, what was the important? I have explained you. Fine. So how many points you have calculated here? Before that, one very important notes for this you can write. So according to thin airfoil theory, okay, if I say symmetric airfoil, so symmetric airfoil, it is what? That dz by dx will be 0, as I told you. Okay. Now make a note of it. What is the node point? Moment at at quarter chord is constant, okay, with respect to angle of attack, means it is not depending on angle of attack, okay. It is constant, it means what? Now just now you have seen it is 0, okay. And with respect to angle of attack, according to thin airfoil theory. All right, where will be what is the C by 4? That is the quarter chord. Here at the same aerodynamic center will also exist at quarter chord, okay. That's the reason I told you at quarter chord center of pressure and aerodynamic center will exist for the symmetric airfoil. All right, M C by 4 only depend on camber, okay. It will not depend on angle of attack, it will depend on camber of the airfoil. If it is cambered airfoil, then moment will be there. If it is symmetric airfoil or thin airfoil, then moment will be 0. Let me write this point also. MC by 4, it is 0, okay, for symmetric airfoil. All right, like here you have seen the aerodynamic center or center of pressure, it is existing at quarter chord, but at the same point, if it is supersonic airfoil, so it will shift on 50%, C by 2, okay. This is for what? This is for subsonic flow, but C by 2 will be the aerodynamic center if it is supersonic flow, okay. It will be shifted. These are the note points you need to remember. It's very special, very important. What parameters I have calculated for thin airfoil? Okay, so general equation we have seen. We have seen what is the circulation, we have seen the lift, we have seen the CL, we have calculated moment about leading edge, we have calculated pitching moment about leading edge, we have calculated pitching moment at quarter chord. These are the parameters. All parameters value you need to remember. I'm sure nothing will be missed. Whatever you have calculated or what you have here done in this thin airfoil, that is more than enough for your delta P also we have calculated, right? delta P also you have calculated. So as per my conviction, if you do this much also more than enough, no need to go for more and more. All right, fine.